Today I want to start animating in React, build a small framework. Now I'm going to try out a new format. This is going to be a long single take video of me struggling through developing this, and I'm going to upload both this version and a edited down version for those that actually care about the long difficult process of actually designing something like this. I'm aware that most people won't be actually interested in watching me struggle through it, but I do hope that it is a valuable experience for some. Right. I'll be clearing my throat a lot. I'm still sick. And I do ask for your apology for that. Let me just turn on some music for myself. You won't hear it, but I expect this to take a while. Okay, so what I've set up is just this box here and a experiment here that scopes some CSS. The CSS is simple. It's just fixed width height, centered in the center of the screen, and give it a thick border that we can see it in the small window in the bottom right. So let's start actually thinking about what is it that we're trying to do. Well, what is animation? Well, animation is just the change of state over time. I can't type. Animation. So we have some sort of state. The system has some sort of state, and the next system state depends on the previous system state and some interval of time between. So if we want to formalize it, it would be the system state at time t equals the system state at the previous system state, and there's some sort of transition function with duration. That's basically the formula for animation. And that is what we're going to implement. So I'm going to do it a bit quick and dirty first, and then we'll try to refine it. And let's move my cup. I don't want to throw it off the table. And then we're going to refine it and see if we can improve the design. Christ, someone tagged me. Wait, tag me. Where was I tagged? Why was I tagged? Yeah, don't care. Anyway. So, what we want to animate is actually this value here. The angle. First off. And the angle is in radians, so if we type in here math.pi, we won't see anything because that's half a rotation. But if we give in math.pi half, which is a quarter rotation, we should see the square not do anything because it's a quarter rotation. We need an eighth of a rotation. Now we see something. So let's do it the very naive approach. Just with a interval. Let's define some constants. frame rate. 60 const interval. And okay. We'll need some sort of state. What is the current angle? Down here. And now we want to animate this angle, so we take a use effect. Yeah, this is a const. Set interval. Move into the next line. Return. I'll explain the code in a second. Let me just. Type this out. Let's call it full rotation. Okay, so what we did here, we set an interval which will fire an event every interval milliseconds. And we then update our current angle just by the rotations per milliseconds. Times 2 pi, because we are using radians, and then we reset to 0, because otherwise the number would get larger and larger. And floating points have more and more gaps in the higher range. So there's as many floating points between 0 and 1 as there are between 1 and infinity. So we want to keep our floating point numbers as small as possible to keep precision. And since we are animating something and this animation might take a long time, we don't want to get into very high floating point numbers. And resetting to 0 is fine. We could just do it on a quarter rotation because we're animating a square. But that is fine. And finally, if the component unmounts, we want to clear the interval. So it's just good practice, and you should just do that. Right. It's technically all we need to do animation, but I can see, and I don't know if you can see that. Let me switch to the browser. It's not a smooth animation, and I have no idea if that'll come across. Maybe I can zoom in a bit more. Yeah, I don't know if you can see it. It's like subtle, but it's jittering. And that's because, and I did some research into that beforehand, and how to animate in a browser. The browser doesn't like that we forcing the browser to constantly do a reflow event when it's not done with the previous stuff, basically. And it would much rather prefer if we asked it when to render. And there's a special function for that. And let's use that function, actually. Actually, there's another reason. Let's fix that first. If we look at the actual interval here, that is not actually correct. Set interval promises us that it will fire the event at not before that time has passed. Nothing else, so it can fire later as well. And it will fire later. So if we measure our actual progress, and if we look at the browser, and let me remove the log statement, we can see that it's actually not consistent updates speeds here. So it's going between different values. And that's partially responsible for the jittering, but I already know that we also need to do the other thing. So we replace just the interval here with the delta, and we should actually flip those. It should be now minus before, because now is always going to be bigger than before, or at least as big as before. And at this point, the frame rate is going to be also controlled by no, it's not. But we still control the frame rate, but the actual rotation update is now based on our actual progress in time. That's much smoother already, but I can still see it chug every, like, I guess it's like every 20 frames or something. Is that more obvious? Oh yeah, that's more obvious if I increase the frame rate. We can... I don't know if you can see it. And I didn't have the browser focused. Terribly sorry. But anyway, all I did... I'll show the code in a second. But we can see that the square is really struggling. If I go back to the browser, all I did is have a before here, a const now here, compute the delta, set the delta, and replace the interval with the delta. That's all I did. And I turned up the frame rate so that we have so that we're actually stressing the browser. Instead of this, we should use the request animation frame. I believe it gives us the actual now. And what type is DOM high-res? It's a number. Okay. We have no method of knowing what the now is now, because we're going through the cool handle here, so if before equals to null, then we set before just to now. Otherwise the rest stays the same. We're going to compute our delta. We're going to reset our before to now. Then we're going to set our angle. And then we're going to cancel our request animation frame with the animation handle. Before not undefined, that should be a number here. Okay, there we go. Now this won't work because request animation frame's just one frame. So we need to turn this into a loop by calling request animation frame again. So let's extract this into a function. This in here. Animation step. And that is a high res timestamp, and I should actually type it the same way here. And this is still an let. Animation step. And we want to then call this again with animation step, and we need to declare this thing beforehand. And remove a let here. I guess I need to type you as a number. Okay. If I go back to the browser, it's a smooth animation now. We have lost control over the frame rate. That's handled by the browser now, but it should be handled by the browser because the browser is essentially our render engine, and it should decide when it's capable of rendering something or not. And request animation frame, it allows the browser to optimize the actual animation, the DOM changes. Let's move this just to the top here. Now, this isn't very useful, and let's say we wanted to animate another property. We'd need to repeat this entire code, so let's try to extract this into... Let's start with a hook first, because that's easy. So, we have design decisions to make. Do we want to animate using hooks? Higher order components? Do we need a context? Those are some questions we're gonna keep in the back of our minds. But for now, we're going to need a hook because it's easier. Because I can just replace the use effect with that hook. So we're going to take actually all of this and throw this all into a hook. Let's call it linear animation. Put it all in here. Return the angle. And let's call it down here. So this should still work. We didn't change anything, but this isn't very interesting because we hard-coded everything here. So let's pass in our initial state. And that's where we start instead. It's still not very interesting because this update rule here is hard-coded, so we can only run in the range from 0 to 2 pi. Let's also extract this. And it has two parameters, previous and delta. This section here, because delta is being computed here. Update rule takes in a previous, or let's call it state, which is a number, and it takes a delta in, which is also a number, and it's supposed to return a number. And we can just take this entire chunk here, and instead call here the update rule with the previous and the delta. And here we can pass in our update rule like so. And this still will work. There's no reason to call this angle anymore. Let's call it state. And we can now animate multiple values. So let's say we also want to animate the x value. We won't see anything because we're moving just a few pixels at most and very slowly. Let's make it a smooth back and forth of our x and multiply it by some value so that we can actually see some movement. That's not very much. Okay. So we see we also animated another value by just reusing our linear animation. Not an issue. We could also send it in make it spin in a circle, but for now this is good enough. And what else do we want to do? We want to right. So right now everything needs to know this user animation, call the hook, set everything up, pass it in. So let's say we wanted to make another animation. We'd need to create another box element. Actually, let's extract this into a box animation function. Component. Like so. So if we wanted a second box, we need to make a box animation 2 and then animate it by going the other direction, for example, and then we can say box animation 2. Stop my linter. And then we have 2 animations. Now I don't like that. We'll have to fully define a component every time and do this. I'd much rather use a higher order component to do this. So let's think about our higher order component. Let's call it with animation or with animated props. A higher order function takes in a functional component, or in my case it'll take in a functional component. It's going to be generic. And it's going to return a functional component. What is this VNFC? This is my own functional component definition, and that is because if we go and look at the React functional component here, we can see that's not actually a function. It's a object with multiple things, and I have a video on this. But TypeScript has issues propagating types on non-functions. So let's say you have a let's say this t would also be a generic argument. So that the props here of box would also take a generic argument. We would lose that generic argument if this is not a function. Why? I don't know. But that's the way TypeScript is. And this allows me to bypass this, because functions actually propagate their generics properly, unlike objects. It's a pity. I would really wish they change it, but yeah. Anyway, for now I can just return cop when it actually doesn't crash. So, what do we want to do? Now, I want to animate the props, but maybe I don't want to animate all the props. So what should the interface of this thing look like? I want to animate some of the props, leave the others, remove the animated props from T. Because the new component shouldn't accept the animated properties anymore here. Let's say we animate angle and X. Let's say we animate angle, then we should still force the user to specify an X, because there's no value for X for type safety. Yeah, so that is the typing we want. We know we are going to have some argument here which will specify what we animate. Let's create a type for that, animated props. We also know that whatever was animated, we do not want to return in our final state. So let's remove the keys of his animated props. Here. And let's make this a generic argument, because otherwise TypeScript will complain that these animated props here are not necessarily the same. And now it actually complains. Before it didn't. Because it said, well, it's going to be any of it, and right now it's just empty, so whatever. And let's continue on. We know we'll need our wrapped component, which will take as props this thing here. And we're going to return the wrapped. Let's think more about our type. So we want to, for every property, we want that to make animatable. So let's make this a map type. Let's make them optional. And let's say we want to support multiple types of animations at some point of time. So let's say it's linear. It has an initial value. Basically everything the use animation here, use linear animation has, we need to specify here. Initial. And let's generify this actually. Sorry. T of prop. So this is the same type the property has. So in a map type here, this syntax here, this makes it optional. And this will iterate through all keys of T and map them. So this key here will be mapped to a different object now. And T of prop here, that is the original type of this prop in T. And this is then a state of type T and a delta ms, which is a number, and that should produce a T again. And let's make this use linear animation actually generic. Right now we can only animate numbers, but there's no reason why we should only be able to animate numbers. So now we are mapping any arbitrary state. Nothing broke, because why should it? And the next step is to actually make this work. Let's look if this does actually what we want it to. So let's say we make a const animated box. Okay, and it'll complain that we are missing angle and x, which is correct because we haven't specified angle or x. Let's specify angle. Let's steal the update rule from somewhere. Numbers not assignable to type box prop. Okay. Let's look at our type. And I wrote T here. Shouldn't be T. It should be, again, the type of T, not the actual T. Anyway. Now, we should be only missing... down here. Now it's complaining that we are missing X just. So the typing works correctly. Obviously, it's not going to do anything. But it correctly detected that we have this thing here. Now, since we made these optional, we can also do this undefined here. And then all errors will disappear because, well, we also defined X. But this makes no sense because we didn't define X. It's just undefined. So let's also fix that. Let's add a type. Let's call it ignore undefined. It'll take in some T. Let's call it P in key of T as P of T. I'll explain this in a second. It should be T of P. Why am I flipping it? So, we're mapping over all keys. That's we already saw the syntax, but this as here allows us to transform our key. And our key does not exist. We're mapping it to never. That is a value that never exists in TypeScript. We're mapping it to never if our key happens to be undefined. As in, if the value of our key happens to be undefined. Otherwise, we just leave it as is. And now we can throw this part out of our key of animations. Like so. I messed up my bracketing, I think. Right? And now our error should show up again. It does. Because X is missing, because it's undefined. This makes no sense. Right. So, our typing setup. Let me shift. I was sitting on my leg. Ow. Fell asleep. Give me a second. Let me switch music while I'm at it. And give me a random other playlist. There we go. Now to the interesting part of making this actually work. Let's actually provide this a fixed X for now. so that it'll stop complaining. We can return our original component. And just propagate the props that we received. Here. Next, we want to grab all the properties that we actually have. So, let's grab our actual entries from Animated. Let's filter them by actually defined values. If you remember, we are just actually excluding them out of a return type. We can't. We're allowed to put define undefines on the input, but we don't want them in our output. Now you can't see this, but TypeScript's doing a thing again. That is the typing it suggests. String unknown. I don't know why it does it. I find it very irritating, but the object dot functions lose typing a lot. And it really annoys me, and it's a pet peeve of mine. But it is the way it is. So, let's type this as key of animated and animated key of animated. Okay. And this needs to be narrow. So, the new typing here, key of animated are just all keys in animated. And these are all values in animated. So, we know that the key is always a key into the object and value is always a value of the object. It's not necessarily paired correctly here, but for our purposes this is good enough. And noticing that it's saying here string key of is going to be actually more than just string. Key of will be also numbers and symbols, but we'll just get strings out. So let's restrict this to actually just strings. Like so. And let's just extract this into a local type. What do we call this type? It's just animated props definitions. Let's call it that way. Definition, since it's a singular in this case. Okay. Just that this line is shorter. Now we've got all our props. Let's do something that'll look a bit iffy for React, but trust me, this is fine. Let's map our animated props here. We got the prop, and we got our specification or definition. And if our specification is of type linear, which currently we only have linear ones, but then we return our use linear animation with our two parameters of our update rule and the initial. Now TypeScript is complaining about a bunch of things here. One is that object's possibly undefined. It's not, because we stripped out the undefined ones. We already know that here. But undefined is technically a legal key. In here we could do this, I guess, instead of animated each time. And then it should know that it's always defined. No, doesn't? Okay, doesn't matter. This is good enough. And the second thing is, it'll complain that we're using, and that's what I meant by iffy, React hooks conditionally. Now we're not. This is a constant array of hooks. There are methods of doing this that will not cause it to complain here. We could use a component with a callback that just returns directly the element of this hook. But honestly, this is fine in this case. And in the other case, we're going to throw an error. It's not a recognized animation type. And we can turn this into an object. Animated props. Because we need to return here actually our props. Like so. And then we can pass in our animated props. And let me just inline this here like so. And my front end crashed. Why did that crash? Who knows? Let me restart my front end. There we go. And this should be prop. Okay. It's complaining about something here. Let's take a look at the error. Let me copy it. Oh my god. So some TypeScript type soup. And it's complaining that this type here is not assignable to intrinsic attributes and T, and as not assignable to T. T could be instantiated with an arbitrary type, which could be unrelated to omit T. I kind of disagree. But would this work? When this is the returned, let's call it new props. This here. Let's instead return the new props. And I'll continue complaining. I mean, this is easy to fix in this case. The reason it's complaining is that T is specified by the caller, not the implementer, but we're defining it here as the implementer. So it's claiming the generic argument here could be anything. Like, for example, someone could also write here a XY something, and this is legal. Here. And so it could be of any subtype, which is technically correct. We could think about restricting this, but to be honest, this is fine. It's not worth it. Right now, at least. Okay, so we've got our animation here. Let's say we want to also animate the X on this one. Let me remove the other ones. This isn't gonna work, because if we look at our animation here, our linear animation is doing here something afterwards. So it has some... This state is not what we are rendering, actually. So we'd need an additional step between the state T here and the update rule. Now, in an ideal world, I would just write something like prop from state and have here a function that turns the state. Let's say this is some state, this is some state, this is some state, and that just turns this state to T. But in TypeScript, there is no way of syncing a hidden inner generic type into an object. Just doesn't work. We could kind of hack around with functions, but then we'll also get the error of, which we had here, that it could be any subtype. But yeah, it's just another thing that I'm kind of disappointed in TypeScript with. If there is a way to do that that isn't super ugly, I'm not aware of it. And if you know one, I'd be glad to learn it. But as far as I'm aware, there's no way of doing that. So instead, we're going to abuse higher order functions. Let's copy this. Let's animate X. It'll complain correctly that we now shouldn't specify X. And this update rule is not gonna do it for us anymore. So let's create a function. And let's call it update with state. Sorry. So we'll have some initial state. We'll have a update rule. Actually, at this point, I've written this thing so many times, I'm getting tired of it. Let's turn this thing into a type. We're going to clean this file up afterwards. So this is a update rule. Let's call it animation prop update rule. And this becomes a prop update rule of t. This becomes a prop update rule of t prop. What the hell are you doing? Auto completion prop. And this becomes a update rule of type s. There we go. And then we have a prop from state. The function I would have liked up there, but can't. Which just takes a s and it returns a t. So this also needs to know t. So how does this function look like? Well, it'll have some current state, and that's the thing we want. That's this initial. And then we're going to return another function which will take in a, let's make this return a prop update rule of type t, like so. Which will take in the state and delta that is of type t, and it'll update our current state based on our update rule of current state and the delta. And then we'll return our prop from state of current state. Like so. So we encapsulated some state in here, but we have the same interface as before. So we current this, we captured it in a closure way. So instead of this update rule here, we can now do update with state. It's again going to be a number, our state. Our update rule is actually going to be the same one here. And we'll have a state here, and that's math.cos, our state, times 100. That's what we had before. Up here. Right, and now it's working. We can see it's animating. Closure. Right. We could also now generate them just by calling this function with multiple arguments without any issues. We don't need to fumble around with hooks anymore. We have an interface, our properties here get removed as we want. Let's add some utility here. That is just nice for debugging. Because if we go and look at our browser in a second. What's it complaining about now? Go to the browser, and if we look at the actual components here, it's called wrapped. This is our wrapped here, which is not a very nice name. I picked this name here. We'd like to preserve the name of the original component. So let's do that. Comp as component type of T, display name. If a display name doesn't exist, then we'll use comp.name. If that doesn't exist, we'll use anonymous as the name. And now before we update the wrapped, return the wrapped, we'll assign it a display name. So let's just copy this line here. And this is wrapped. We don't actually need the typed thing here. And that becomes a string of the original name. And if we use, if we write it like a function here, then React will actually be nice to us. Let me just calm down my linter. Keys. If I reload this, now it's called box, and we see this label with animation props here. So it's telling us it's a component of box applied with this animation props render thingy here, instead of wrapped. And that's nice for debugging. Because we know what type, what this is, and that this higher order component is applied to it. Okay, and we've got a circle spinning in a square spinning in a circle. Let's invert our rotation so it's counter-rotating. And yeah. Right, that's it for today. And if you find this interesting, subscribe. If you have any questions, please leave a comment. And see you around.